This is practice final 3. I'm dividing this one into 3 videos so that they don't get too long. So the first one, it's match the function y equals 9 cosine pi over 5x to the correct graph. I like these because I can eliminate a few just by process of elimination. If I'm looking at the graphs, first thing I'm going to do is look for a cosine graph. It's not shifted left or right, so my cosine graph should start at, if it doesn't have an amplitude, start at 1 or -1. This is a positive cosine graph, so it's going to start at this positive value. So my graph should start at +9. So this is actually the only graph that starts at +9. So I would automatically pick it. The other way to rule a few out is to look at the period. So the period of my graph is one complete cycle. So from here to here, your period is determined by 2 pi over this value here. So in this case, the omega is pi over 5. So 2 pi divided by pi over 5 is actually 10. So notice from here to here, it's a distance of 10 units. So this period is correct. So I would definitely pick this graph. Next one, more composite inverses. When we have the angle on the inside, we automatically go to this angle. So don't even worry about this yet. We're going to focus on the sine of -5 pi over 3. So -5 pi over 3 is here because, oh, sorry, -5 pi over 3. Sorry, this is -3 pi over 3, -4 pi over 3, -5 pi over 3. I'm right here. So this, my reference angle, is pi over 3 or 60 degrees. So what is my sine of 60 degrees? It's the square root of 3 over 2. So now if I have the sine, if my sine of -5 pi over 3 equals square root of 3 over 2, I replace this with my square root of 3 over 2 and I focus on cosine inverse of square root of 3 over 2. I don't even look at this anymore and I draw this one. So where's my cosine inverses? Positive in quadrant 1. The square root of 3 over 2, what angle is that? It's 30 degrees or pi over 6. Okay, here's another identity. They love this common denominator stuff. So what we're going to do is we need to multiply this side by sine of theta over sine of theta, and this side by cosine of theta over cosine of theta. What happens then is I get sine of theta cosine theta minus sine squared of theta over sine of theta cosine theta minus, and here we get cosine squared of theta plus sine of theta cosine theta all over sine of theta cosine theta. Now I can combine my fractions because they both have the same denominator. But look at this. Sine of theta minus sine of theta cosine theta minus sine of theta cosine theta, they go away. So this becomes, watch your signs, minus sine squared of theta minus cosine squared of theta over sine of theta cosine theta. What is this the same as? It's the same as -1 times sine squared theta plus cosine squared theta over sine of theta cosine theta. This is 1, right? So my final answer is -1 times 1, so -1 over sine of theta cosine theta. Final answer. Sorry, I ran out of room there on you. Last one, solve the equation. This is a nice basic one. We need to find, get secant of theta by itself. I'm going to subtract the 9, so I get 7 secant theta equals -14. I'm going to divide by 7, so my secant of theta equals -2. Where is my secant negative? the same places that my cosine are negative. Quadrant 2 and quadrant 3, negative x-axis. So my secant is hypotenuse over adjacent, so I need 2 over negative 1. Same thing here, 2 over negative 1. This is a 60-degree angle, so it's, or pi over 3, so we go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So my two answers are 2 pi over 3 and 4 pi over 3.